This is lesson 37-1. We're going to learn about changing the dimensions. How does that affect your measurements of your shapes? And this one is particularly about cubes and spheres. So, Howie Shrinkett builds scale models for museums. He is commissioned to build models of the solar system, for the Hubble Planetarium, models of the Egyptian pyramids, and models building the house of the Cubanism Museum of Modern Art. All right, so he's got to build some models. He's got some cubes. They're in the shape, they're for a keychain, a paperweight, and a planter. So they're different sizes, and they want us to fill out this chart right here and find the area, the surface area, and the volume. So I put these over here so that I could very prettily draw these cubes. I could not have done that with my pen on the other page. So we'll fill it in right here. So we've got a cube. They want the area of the base. I shaded the base. So the area of a base, it's a square, so it's length times width. 1 times 1 is 1. And it's in cubic inches. So this is 1 inch, and I'm putting the units right here on purpose. This is 1 square inch. And if I find the surface area, the surface area, of course, I could use the surface area formula that you've learned, but I also, since this is a cube, and I think that's why you're learning the cubes first, just because it's allows us to think about this without having to whip out our formulas. But we have this surface area right here. There's how many? 6 surfaces: the top, the bottom, the front, the back, the left, and the right. And they're all going to have 1 cubic inch. So if there's 6 of them, it'll be 6 cubic inches. And that is an I right there. It looks like 61. And then the volume is 1 times 1 times 1, length times width times height. So the volume is 1 cubic inch. Okay, so we have 1 inch for the edge length. The area is 1 times 1, so that's 1 square inch. The surface area is 6 square inches because there's 6 surfaces that each have an area of 1 inch, 1 square inch. And then we have a volume of 1 cubic inch. Okay, we'll do the same thing for this. It's 3 inches. So the area is 3 times 3, so that's 9 inches. And we've got 6 of them, so 9 times 6. What is that, 54? Well, that's my 4s always look weird. And then 3 times 3 times 3, I believe, is 27 cubic inches. Forgot my squares on here. And then the last one is 9. So the edge is 9 inches. So the area, 9 times 9 is 81. That's the area of the base. And then we have 6 of those. So 81 times 6 is 486 inches squared. That's inches squared. And then 9 times 9 times 9 is 729. Okay, so we've got that filled in. Now let's go back and see what number 2 wants us to do. It says, Howie observed that as the length of the edge increased, so as this increased, so does the resulting surface area. So the surface area also increased. He wants us to see if we can make a conjecture about how, as this changes right here, and these were being tripled. So we went from 1 to 3, we tripled it. Then we went from 3 to 9, we tripled it. So what was happening to the surface area? Let's see if I can remember what these were. This was 1, and then we did 3 times 3, which is 9, And then we did 9 times 9, which is 81. And then this was times 6, right? So that was 6. 9 times 6, I believe, was 54. And 81 times 6 was 486. And then this was 1 time 1 time 1 time 1 time 1 time 1. So that's 1. 3 times 3 times 3, 27. And then 9 times 9 times 9 is 729. So as the length tripled, we were multiplying. We said this times 3 to get that, and we said that times 3 to get that. Okay, what happened to the surface area? Well, this wasn't times 3, this was times 9. Times 9. So is this 9 related to this 3 in any way? Well, yes, 9 is the same thing as 3 squared. 9 is the same thing. Ooh, that does not look like a 3. 9 is the same thing as 3 squared. So I wonder if this has any connection to the fact that we've got inches up here and we've got square inches up here. Oh, and that's just the area of the base. I didn't even look at this. Let's see how this changed. I'm supposed to be looking at the surface area. How did this change? 6 times 9. This one was also times 9. And so it's the same relationship because this is inches squared. So that would be 3 squared. 3 squared. All right, so they wanted me to make a conjecture about how the surface area changes. And then it says use your conjecture and the information from the table to predict the surface area. So my conjecture is that if the edge tripled, the surface area increased by 3 squared. So tripled means times 3. So this means times 3 squared. And that kind of makes sense because I'm going to jump back over here. Because remember, this one right here is 1 times 3. And this one right here also got tripled, 1 times 3. So when we were multiplying 1 times 1, we're now multiplying 1 times 3 times 1 times 3. So we have the original multiplication right here, but then we've got this 3 times that 3. Same thing right here. When we triple this one, we have these that we originally multiplied together, but then we have those new times 3's, the increase, and we multiply those two together, and we've got 3 of them. And I'm getting ahead of myself. So it says, make a prediction. So if the surface area, use your conjecture and the information from the table to predict the surface area of a cube whose edge is 27. So I say, instead of having to find this, I just take this right here and multiply it times, because this is times 3. So I'm going to multiply this times 3 squared. 486 times 3 squared is 4,374, and that would be square inches. Then verify by revisiting your conjecture from part A. So if we go over here and we do, I did it backwards. I did my conjecture from part A first. So if this is 27 by 27, then we'll have 27 squared. And that will give me, this area right here will be 729. And then we have 6 of those. And we get 4,374. So I was right. So this 729. And then we take this and we say times 6 to get the total surface area. And we get the same thing that we did when we just take 27 and multiplied it times 9. Use your conjecture. Okay, so we did. Then verify. So our conjecture was verified. Express regularity and repeated reasoning. Howie also observed that the length of the edge increased, so did the volume. So they want us to do the same thing for volume. Okay, so this is obviously 1 times 27, and this is obviously 27 times 27. So this looks like it's being multiplied by 27, but I wonder, is the relationship between 27 and the original increase in the side length? Well, if you don't recognize it, 27 is 3 cubed. So the original side length tripled and the volume increased by 3 cubed. Now, what is the units for volume? Inches cubed. That's going to be your clue. If you change inches by 3, then you're going to change the one that has inches cubed by 3 cubed. That's just a very simple reminder. So if this one right here is 27, then this one is going to increase by 3 cubed. So 729 times 3 raised to the third power is going to give you 19,683. And again, we could figure that out if we just said 27 times 27 times 27. 27 raised to the third power is 19,683. So verify it. So yes, if the edge tripled, then volume will be times 3 cubed. That's how will the volume increase. Okay, so he also observed that as the length of the edge increases, oh, we did that one already. Oh, this is the answer to this right here. Okay, so we did all 3 of those. All right. For the Hubble Planetarium, Howie did some spheres. Okay, so the surface area of the sphere is going to go from 12 to 6 to 3. You see that that's times 0.5 and that's times 0.5. So this is how the radius is changing. The surface area, and they tell us right here that the surface area is 4 times pi times the radius squared. So the radius is 12. So we're going to say 4 times pi times 12 squared to get this number right here. And 12 squared times 4, that's 576 pi. Okay, and then we can go ahead and do the volume by taking 4 times 12 cubed and then dividing that by 3. And that is 2,304 pi. Okay, now if we do it with 6, this is halved. I'm saying that this is going to be reduced by half squared. Because why? This is square feet. And so whatever the change is in feet, if we square it, then that will be the change here. So I'm going to go ahead and use the formula to get the surface area. And the surface area is right here, 4 pi, and this time it's going to be times 6. 4 pi times 6 squared. So 4 times 6 squared is 144 pi. And then this is going to be I believe this is going to be 288 pi. Now this is square feet, and this is, oh, I'm doing inches, sorry. Feet, feet, feet cubed. This is cubic feet. Okay, so what I want to do is see how much this reduced by. So you take the difference. So 576 pi minus 144 pi is 432, and then divide it by how much you started off with, 576, and it comes out to be 0.75. So that's what we kept. So the difference, which was 144, divided by 576, what you started off with, that comes out to be 0.25. So that means that if you multiply this right here times, see, 576 times 0.25, you get 144. So this was times 0.5 squared, just like I anticipated. And I'm assuming that this one right here, the change right here will be the same, but I'm going to go ahead and do 4 pi times 3 squared. So 4, that's 4 times 9. 4 times 9, I believe, is 36 pi. Now, if you multiply 144 pi times 0.025, no, 0.25, then you get 36 pi. So just like I predicted, you take the change in the linear measurement in the radius, which is kind of like an edge. You take the change in the radius, and to find the change in the surface area, you square your change. What are we going to do over here to find the change? We're going to take that 0.5, and what are we going to do to it? We're going to cube it. So take this and multiply it by that, and I bet you get 288. So 2304 times 0.5 cubed, and you get 288 pi. And if you want to know what this number is, you take 288 pi and multiply it times 0.5 cubed pi, and you get 36 pi. And if you do it by the formula, you're going to get 4 times pi times the radius cubed divided by 3. That's the formula for volume right there. So that's going to cancel out with one of those, and that's going to leave you 36 pi. Okay, so he observed that as the radius decreases, so does the resulting surface area. Make a conjecture about how the surface area changes when the radius is cut in half. The surface area, if the radius is cut in half, the surface area will change by 0.5 squared. If this is the radius is changed by 0.5, then the surface area is going to change by 0.5 squared. That was my conjecture. Make a conjecture that if the surface area is 1.5, verify. So 1.5. Then this one right here, take this and multiply it. And this is what they're hoping that you'll see, is that this is a ratio. So if you say that 0.5 over 1 is equal to, and that's the ratio, then is equal to, this would be, well, let's do it like this. This would be easier. You do 3, which is the length of the radius, over 1.5, which is the length of the new radius, and we say that that's equal to 36 pi. That's the surface area of the one with 3. So what's the surface area of the one with 1.5 going to be? You cross multiply and divide, and you get the answer. So 1.5 times 36 pi divide it by 3, and you get 18 pi. So I believe that that's going to be 18 pi. And if you take 36 and multiply it times 0.5 squared, I bet you get, no, that's just 0.5. Oh, I forgot to square this. That's what I did. Okay, I messed that up. Maybe I'm getting ahead of myself. I think that's the next section. So, because I forgot to square it, I should have done 0.5 squared. So, then that's not 18. You do 36 times 0.5 squared, and you get 9. And if you plug 1.5 into the formula right there, and you multiply that times 4, you get 9. So I'll show you the ratios, the proportions are coming up in just a minute. I just got ahead of myself. I was being lazy actually. So use your conjecture to predict the surface area of a sphere. So we said it was 9 pi. And we predicted that by doing 36 times 0.5, 36 pi times 0.5 squared. That's how we predicted it. He observed the same thing was happening to the volume, and we're going to make a conjecture that if the radius goes down by 0.5, then the volume would need to be multiplied by 0.5 cubed. So the volume, this 36 right here, would need to be multiplied by 0.5 cubed. So my conjecture would be 36 pi times 0.5 cubed would give me my new volume. So 36 pi times 0.5 cubed, and I would get 4.5 pi. And that's what would go right there, 4.5 pi, and of course that's feet cubed. And again, the reason that I needed to cube my 0.5 is because I changed, the dimensions is cubed. So the change happened 3 times. Okay, Howie recalled that similar two-dimensional and three-dimensional figures are those that have the same shape but not necessarily the same size. Does this imply that all cubes are similar to all other cubes? Yes. And does this imply that spheres are similar to all other spheres? Yes. Because there's only one dimension. So if you change one dimension, you're changing the length, the width, and the height. So they're going to be proportional. A sphere only has one dimension. So if you change the radius, it's going to be dimensional. Okay, so that leaves you to do your practice, check your understanding, and lesson practice. My next video will contain the answers to these.